In this video, we're going to try to sketch the graph and name all the asymptotes for the g of x function. So the first thing I'm going to do is take a look at that graph. And so I go to my graphing calculator. I've typed this in the y equals. You'll notice the parentheses around the denominator. I have already set my window as zoom and then option 6, the standard window. And so I have this graph in 3 pieces. Now, if you're having an older calculator, you're going to see these 3 pieces being connected because the older calculators attempted to draw the vertical asymptotes or poles. And so you do not see them on the newer calculators, but on the older calculators, they're going to attempt to draw these. But the 3 pieces I'm seeing here, this is the actual graph. So going to my PowerPoint, my graph went from -10 to 10, -10 to 10. This was my x, this is my y, and I have 3 pieces. So I have a piece here, I have a piece down here, and I have a piece here. Now, on the older calculators, it's going to have like a sort of line in here and again in here because it attempted to draw the poles. And those are not actually part of the graph. So I'm going to erase them, but depending on your calculator, you're seeing that. It looks almost like kind of like a W shape because it drew in the poles for you. Get rid of those poles. They are not actually part of the graph. So when I sketch my poles, I typically sketch them as dashed lines. And so we see that this clearly has a pole here and a pole here. And a pole is literally like a flagpole that separates the graph. And so we have this graph, and then it like goes up the flagpole, and then we have this next one starting to climb. It goes down the other flagpole, and then we have this one coming down. So we have those poles. We want to know where they are. So those poles are asymptotes, and they are the vertical asymptotes, which appear to be poles in the middle of our graph. They occur when the denominator is 0. So I make this denominator 0. And I'm going to solve this by subtracting, or rather adding 9 to both sides. So x squared equals 9. Opposite of squared is square root, so I'm going to square root both sides. So x is plus or minus 3. And so that looks right. I see that this pole right here is at x equals 3. And this pole, excuse me, that's the -3, is at x equals +3. I'm going to go back to the calculator a moment, and I can literally, if I count these 1, 2, 3, I can see that the pole would be at the -3 and the pole would be at the +3. Now, I also see, as I'm looking at this, that there is a horizontal asymptote. I could draw a horizontal line, and the left and the right would both go towards that line. So the way that we get the horizontal asymptote, which is also referred to as a limiting value, is by comparing the exponents, which are the degree. So when I compare the degree of the top is 2, the degree of the bottom is 2. So I look that up in my notes. When the degrees are equal, which is what we have one asymptote at y equals ratio of leading coefficients. So going back here, one asymptote at y equals ratio of leading coefficients. So my leading coefficients are 5 and an unwritten 1. So 5 over 1, which would simply be 5. And so again, I'll draw this in as dashed right across here. There is a horizontal line. Both the left and the right go to the same horizontal line, and that is at y equals 5. So 1, 2, 3 different asymptotes, 2 vertical, 1 horizontal, and a sketch of the graph.